Time and tide wait for none, and time once lost cannot be recovered. I think you can agree on that. You can ask the importance of time to an Olympic runner who prepares himself for the biggest competition of his life. Time is the most important resource and you should never waste time. Can you think of a system from our everyday life that saves time? I think you might have a few names on your mind, but I'm talking about the traffic light system that enables safety and security in our everyday life. In today's session, let's design a circuit for traffic light system by using the components that we are aware of. Now, you're familiar with Arduino and controlling the Arduino using block coding. We have designed circuits to turn the LED on and off using Arduino. Then we tried to make the LEDs blink by using Arduino exactly similar to car indicators. We also made different beautiful patterns to turn the LED on and off similar to party lights. We also tackled the limitation and connected more LEDs to the Arduino and then we turned them on. Are you ready to design a circuit for traffic light system? We all are familiar of a traffic light system from our day-to-day life. We know that a traffic light system consists of 3 colors. The green signal allows you to drive ahead, while the yellow signal is a warning signal, which indicates that the red signal is about to be displayed, while the red signal indicates stop. So, are you ready to design a circuit for traffic light system? Well, let's get started. Let's add the components first. The most important component to control the working of the traffic light system is the Arduino Uno. So let's drag and drop an Arduino Uno to the workspace. Zoom out the workspace a little to place the rest of the components. A traffic light system cannot be made with few LEDs. We will have to connect many LEDs. Therefore, we require breadboards to connect LEDs to the Arduino. But how many breadboards do we require? We are going to design a traffic light system for a 4-road junction. So we can select 4 small breadboards, where each breadboard represents 1 road. Drag and drop a small breadboard to our workspace. And this is our road 1. Let's do it again. And this is our second road. Here I am placing the 3rd breadboard to represent the 3rd road and rotating it to place our LEDs in an order. Here I am placing the 4th breadboard and rotating it to get aligned. And the 4th breadboard represents the 4th road. So this is our junction and these are our 4 roads. And now we need to add our traffic lights. We can use LEDs to represent the traffic lights. So let's fix LEDs on all the 4 roads. So we need to place a red LED, yellow LED and a green LED on all the 4 breadboards. Let's add the LEDs to the first breadboard. Select an LED from the component library. Change the name of the LED to LED 1 and let the color remain red and place it in the breadboard. Select another LED from the component library and place it here. Change the name of LED to LED 2 and then switch the color to yellow. Now we need another LED to indicate the green signal. So select an LED from the component library and place it here. Change the name to LED 3 and switch the color to green. Select an LED from the component library and place it here. Let's name it as LED 4. Here we don't have to change the color as it is used for the stop sign. Now I'm rotating it upside down to fit in our second breadboard. Now drag and place the LED over here. Similarly, let's add the yellow and green LED in our second breadboard to finish the signals in the row 2. Now let's add LEDs to the third breadboard similarly to what we did in the second breadboard. Select LED from the component library and place it here. Now change the name of the LED and keep the color as red. Now rotate the LED to fit properly in the third breadboard. Then place it over here. Now fix the yellow and green signals just like we did now. Finally, adding LEDs to the fourth breadboard. Change the name to LED 10, LED 11 and LED 12. And switch colors to red, yellow and green. And then fix them in the breadboard. Yes, we have finished setting up our signal lights. Now just count how many LEDs we have to connect to our Arduino. 12, right? So in total, we will require 24 pins to connect all these LEDs. But what we got in our Arduino is a 14 digital pins. So what to do? Yes, in the previous session, we learnt about the common ground concept. We can connect cathodes of all LEDs to a common ground point so that we can provide a negative to all our LEDs. Now, we require only 12 digital pins where anodes of the LEDs can be connected and controlled. So let's connect the ground pin of the Arduino to a horizontal row in the breadboard 2. As the ground pin is closer to breadboard 2. Change the wire color to black and connect the ground pin of the Arduino to one of the horizontal row of the second breadboard. Then connect cathodes of the LED, LED 4, LED 5 and LED 6 to the same row where we have connected the ground pin of the Arduino. Then link a connection between the same horizontal point of the second breadboard where we connected the ground to this horizontal point in the fourth breadboard so that we can share the ground to all the LEDs in breadboard 4. Now connect the cathodes of LED 12, LED 11 and LED 10 to this horizontal point, so that the cathodes of these LEDs will get the ground. Similarly, link a connection between the fourth and the first breadboard to share the ground from the breadboard 4 to 1. Now connect the cathodes of LED 1, LED 2 and LED 3 to this horizontal point to get connected to the ground. Similarly, make a connection between the first breadboard to third breadboard to share ground to LED 7, 8 and 9. Now we have connected cathodes of all the 12 LEDs to the common ground point in the Arduino using breadboards. Now, in order to control the traffic light, we need to connect the positives of all the LEDs to the digital pins of the Arduino. For making an arranged connection in our traffic light circuit, let's start the connections from breadboard 2 to the Arduino pins. First, let's connect our stop sign to the Arduino. For that, change the wire color to red and connect the anode of the red LED to the digital pin D1. So from now on, whenever we make a digital pin 1 high, the red signal on row 2 will turn on. Then change the wire color to yellow and connect the anode of the yellow LED, which is LED 5, to the digital pin D2. Now change the Y color to green and connect the anode of the green LED to the digital pin D3. Well, we just connected the traffic signal of road 2 to our Arduino. Now let's connect anodes of LEDs in the fourth breadboard to the Arduino. Connect the anode of the green LED to the digital pin D4. Then change the Y color to yellow and connect the anode of the yellow LED to the digital pin D5. Change the Y color to red and connect the anode of the red LED to the digital pin D6. Similarly, connect anodes of red, yellow and green LEDs of the first breadboard to the digital pins 7, 8 and 9 of the Arduino respectively. Finally, let's connect anodes of LEDs in the third breadboard to the Arduino. So connect the anodes of red, yellow and green LEDs to the digital pins 10, 11 and 12 of the Arduino. That's it. We just finished the whole circuit of the traffic light system. We are just one step away from designing a traffic light system. I think you guys already know the step. We have to do coding to make our traffic light system work. Through coding, the microcontroller guides the digital pins of the Arduino and the LEDs connected to the digital pins glow accordingly. Click on Codes. Yes, it's time for Mr. X. Thomas Alva Edison strung the first Christmas lights in 1880. Thank you, Mr. X. That was really interesting. Okay, let's start coding to block the road 3 and 4 and then allow the vehicles to pass through the road 1 and 2 so that when vehicles are passing through road 1 and 2, vehicles of road 3 and 4 will not pass and cause accident. Here we need to turn on the red LEDs of road 3 and 4 for blocking the traffic and then turn on the green LEDs of road 1 and 2 to allow vehicles to pass through them. Let's remove the code blocks first. Now we can do the coding to turn on the red LEDs of road 3 and 4. Since this is an output operation, click on the set pin block and drag it to the coding space. Now click on the set pin block again and drag one more block and arrange it under the first one, since we have two red LEDs of road 3 and 4 to turn on. Remember to which pins we have connected the red LEDs of road 2 and 3. Just drag the red connections and you can see we have connected them to digital pins 6 and 10. Now simply set the pin number and set them high in the blocks. Now we need to turn on the green LED for opening the traffic of roads 1 and 2. So right click on these blocks and select duplicate and attach the blocks here. Now all we need is to find which pins are connected to the green LEDs of road 1 and 2. As we have done earlier, track the green colored connections which are connected to the green LEDs and the digital pins. The pins are 3 and 7. Now set the pin number in the blocks. That's it. Let's check out the working. Click on Start Simulation. We can see that the green LED and the red LED lights are on, which means currently roads 3 and 4 are blocked and roads 1 and 2 are allowing traffic. Click on Stop Simulation. Now let's put some delay to continue the traffic for some time. For that, go to the Control section and select Wait 1 second block. Now change the value of delay to 3 seconds so that our traffic through 1 and 2 will continue for 3 seconds. In the next step, we need to keep the roads 3 and 4 blocked and warn the roads 1 and 2 that the traffic is about to stop by turning on the yellow LEDs. Let's do coding for that. Right-click on these blocks and select Duplicate. Arrange it under Wait block. We are keeping the red LEDs on and turning off the green LEDs of road 1 and 2. For that, simply select Low for pins 3 and 7. Now we need to turn on the yellow signal for road 1 and 2 for a warning indication. Drag and drop 2 set pin blocks and drag the pins to which we have connected the yellow LEDs of road 1 and 2. See, they are connected to the digital pins 2 and 8. Now change the pin number on the set pin block and then place the blocks over here. Let's check the output. Click on Start Simulation. We can see at first roads 1 and 2 are allowed in traffic, while the road 3 and 4 are blocked. Then after 3 seconds, the green LED turns off and then the yellow signals turn on as a warning to road 1 and 2. The next step is to block the traffic through road 1 and 2 and then allow the traffic through the road 3 and road 4. So click on Stop Simulation. Then right-click on these blocks and select Duplicate and place it over here. At first, let's turn off the yellow LED of road 1 and 2 and then turn on the stop signal. For that, select Low for pin numbers 2 and 8, which will turn off the yellow signal. Now track the pin numbers of the red LEDs of road 1 and 2, which are 9 and 1. We don't have to use 3 and 7 pin blocks here, which are already low. I am going to use these blocks to control the pins 9 and 1. Here I am changing the pin numbers from 3 to 9 and 7 to 1. And let's set them to high, so that the red LED of road 1 and 2 will turn on. We have blocked the traffic of the road 1 and 2. Now let us turn off the stop signal of the road 3 and 4. Set the 6th and 9th pin to low. Now it is safe to open the traffic of road 3 and 4. For that, drag and drop 2 set pin blocks and track the pin numbers of the green LEDs. We can see that they are connected to the 12th and 4th pin of the Arduino. So set these numbers on the set pin block and place it over here. Now attach these code blocks to our main code. Click on Start Simulation. Initially, green signals of road 1 and 2 are on. Then warning signals are turned on. And then stop signals are turned on, and at the same time, the green signal of road 3 and 4 are also turned on. Click on Stop Simulation. Have we finished creating our traffic light system? Not yet. Now our road 1 and 2 is blocked and we need to allow the traffic through them again. For that, I am initially going to turn off the green signal of road 3 and 4 and then turn on the yellow signal to give a warning. Just duplicate these blocks where we have turned on the green signal of road 3 and 4 and make them low to turn it off. And now drag and drop 2 set pin blocks and then track the pin numbers of the yellow LEDs. They are pin number 11 and 5, right? So set the pin numbers and then keep them high. Now place it over here and then merge it with our main code blocks. Start simulation to verify the output. Well, we have got the exact output. So click on Stop Simulation. Okay, we are about to finish our traffic control. What we need to do next is block the traffic through road 3 and 4 for safe traffic through the road 1 and 2. Duplicate the blocks where we have turned on the yellow signal of road 3 and 4 and then make it low. Now we need to turn off the stop signal and open the traffic through the road 1 and 2. So drag and drop 2 set pin blocks and then track the pin numbers of the red signals of road 1 and 2. We can see they are connected on pins 9 and 1. Set the pins in the block and set them as low. Now place the blocks over here. So from now on, the stop signs of road 1 and 2 will be turned off. Yes, we have finished the full coding of our traffic light system. But wait, we haven't done coding to turn on the green signal of road 1 and 2 to inform the vehicles that they are allowed to pass. Also, the traffic is currently open on roads 3 and 4, which we have to stop, right? But actually, we don't need to code that because in Arduino, as we know, when we reach the last code block, it will automatically go to the beginning and start the code again. Let's go up and take a look. See, we already have the code to turn on the green signals on road 1 and 2 and the red signals on road 3 and 4. Okay, now back to the end. As we don't need the delay between the signals switching, remove the wait block. Now merge this code with our main code and start the simulation. We can see that our traffic light system is working perfectly. Now what if any vehicle is in the middle of the junction when we block road 1 and 2 and allow traffic through the road 3 and 4? Or vice versa? There may be a chance of accidents, right? So for extra safety, we need to add a delay between red signals and green signals. That is, whenever red signals are turned on, traffic through the other roads will be allowed only after a delay. So let's go to Control and select a wait block and place between the codes where red and green LEDs are turned on. First, drag and place the wait block here. So after blocking road 3 and 4, the green signal of road 1 and 2 will turn on, but only after a delay. Now drag and place another wait block over here. So after blocking road 1 and 2, the green signal of road 3 and 4 will turn on only after a delay. Now click on Start Simulation And you can see that a traffic light system is working perfectly. You can change the time delays to control the traffic time, and also you can add extra code blocks to allow seamless traffic between the roads 1 and 3, 2 and 4, and so on. Now I hope you are able to design a circuit for traffic light system on your own. Now comes the final step, that is revision. It is very important to revise your lessons after studying them, as it will help you to remember the ideas, concepts, facts and methodologies. And it will raise your confidence too. Now comes the final step. Let's take a quick look into topic 2. First, we designed a circuit to turn an LED on using an Arduino. We learned that controllers control all the activities in a smart electronic device. And there are two types of controllers, such as microcontrollers and microprocessors. We studied a microcontroller development board called Arduino. We saw that the microcontroller in Arduino controls all the input-output activities, and it is a mini computer that can be programmed to get the desired output. We also studied the different pinouts in the Arduino in detail, and we saw how to interface an LED with an Arduino and to turn an LED on by connecting it to the different pins in the Arduino. When the LED is connected to the digital pins of the Arduino, we saw that they won't work until precise coding is performed. We then concluded that coding determines the output in Arduino, and we saw how to change the coding when connections are changed. Then we designed a circuit to make the LEDs blink using Arduino. We learnt about the different conditions to turn the LED off using an Arduino so that we could make them blink. Then we saw that the LED turns on and off in a fraction of milliseconds, which the human eye is not able to capture. So we introduced wait 1 sec block to create a time span between the on and off of the LED. We also changed the delay time to see the variations in on and off patterns of the LEDs. We made beautiful color patterns using 3 LEDs just like in serial bulbs. Then we designed a circuit to turn the LED on/off using Arduino and breadboard. We were able to connect more LEDs in the Arduino with the help of a breadboard. We also created beautiful patterns of LED blinking and studied to change the block code when the connections are changed. We also learned about the common ground concept. Finally, combining all these concepts, we built a traffic light system using Arduino. Now using these concepts, you can design more circuits with Arduino, LEDs and breadboard. Now you can design a circuit for a traffic light system with pedestrian crossing lights. Nowadays, pedestrian crossing lights are also added to traffic light system to enable safety and security to the pedestrians. Have you realized the importance of Arduino? You can design mini circuits to mini robots using Arduino. When you use your vision with Arduino, the sky is the limit. Haven't you realized how much we use Arduino in our day-to-day life? Using all these logics intact, you can design your future projects very easily. So let's meet in the next session. Until then, bye.